Hey guys, so we've talked about how to calculate speed and velocity and acceleration. Remember, speed and velocity are the same thing. Velocity and just includes your direction of your motion. So now we're going to use a graph to see how we can tell what the speed is actually doing or what the movement of the person is doing through a graph. So describing the motion of an object occasionally is hard to do with words. So we use graphs. So on the bottom of the graph, we have time. This is your x-axis, and time is always going to be on the x-axis. And then distance is going to be on your y-axis. Okay? So we're going to look at these and look at what distance is doing over time, and we're going to match the letters with the graph. So one, we notice my distance is increasing as time is increasing. So it can't be the car is stopped. So we know it's either the car is traveling at a constant speed or the speed is decreasing. Because my line is straight, that means my distance is increasing at a steady rate as time is increasing. So one would be the car is traveling at a constant speed. And the reason for that is line straight equals constant speed. Now, this won't be true on a speed versus time graph, but when distance is increasing in an equal amount, your speed is constant. All right, graph 2. No distance is being traveled. Distance is not increasing. That means A, the car is stopped. So, because distance isn't changing. All right, graph 3. The only one left is the speed is decreasing. So we see we're driving distance, and then all of a sudden it almost comes to a stop. So C would go here because we flatline at the top. Okay, now we're going to match the part of the graph with each description. All right, so we're looking at the graph. We've got distance on the left and time on the right. So the first one says stationary. That means not moving. So the only one I see where it's completely flat is C. So C would go here. What about where we are increasing our speed? Well, we know here, here, and here, we're all, driving, going up. But our speed is constant here because we said the line is completely straight, and it's constant here because the line is completely straight. So what I want to do is I want to skip that one, and I want to come back and see, we know in order for it to be constant, our line has to be straight. So we know that this one is not constant. Returning to start is a really easy one because when your distance is decreasing, you are going backwards. So you're returning to your start right here with E. So C and E are already done. And now I've got these three. So let's look at the ones we know are constant. We know line A and B are constant because they are straight. So one is slow and one is fast. And we can see B, the distance increases much more slowly over time than A. So B would be slow, A would be fast and constant. A is fast and constant, B is slow and constant. And then 5, increasing speed. D is the last one we have left, and it is increasing speed, okay, because we're going at a certain rate, and then we start going up more, but it's not constant, so D would go there. So just to review, the steeper the graph, the faster the motion. That's why A is faster than B. A horizontal line means the object is not moving, it's stationary, and a curved line means we're changing our speed, but we are speeding up. So if it was going down, it would mean we were going back and we were slowing down, okay? So let's look at speed versus time. Okay, this is different. This is not your distance over time. This is how your speed is doing over time. So speed and velocity are plotted on the y-axis. A straight line on a speed versus time graph, that means our speed stays constant. So imagine you have cruise control on. So how is this different from a distance versus time graph? On a distance versus time, a flat line equaled stationary. But on this one, it equals constant speed. So if our speed is increasing, that means you're speeding up. If we're going down, our speed is decreasing. So if your speed is increasing, you're accelerating. If your speed is decreasing, you're decelerating. So there's only one line on here where it's decreasing, and that's D. So I know that's going to be deceleration. Now we have steady speed. We just said if the speed line is flat, we have steady speed. So my speed is steady on B. Now I have steady acceleration and gradual acceleration. Gradual means slow. So do you think A or C would be slower? Looks like C would be slower and A would be steady. Okay, so the steeper the line, the faster you're accelerating. You're increasing your speed. So let's do some practice. We have 4 descriptions up here at the top. We have the car is stopped, the car is traveling at constant speed, the speed is decreasing, and the car is coming back. Okay, so look at that and see what you think. They're all distance versus time. Okay, so they are all distance versus time. So you have to think about where your distance versus time would go. So up at the top, I just always like to write distance versus time so I don't get confused and think it's speed. So we know the flat line, if no distance is being covered, we know that means this car is stopped. So C is going to match number 1. So graph C matches 1 because no change in distance. And let's see, graph B, our distance is decreasing. So remember we said if our distance is decreasing, that means we're turning around and coming back. So B would equal 4 because distance is decreasing. All right, now we only have A and D left, and we have 2 and 3 left. 2 says the car is traveling at a constant speed. Remember we said our line has to be straight. We only have these 2 left. This line is straight. That means we haven't changed our speed. Our distance is increasing. So A would be the car is traveling at a constant speed because the line is increasing and straight. In graph D, it's increasing and then it kind of comes to a flat line. So the speed of the car is decreasing because it flat lines at the top. Okay? Last thing we're going to do is we're going to look at a speed versus time. Okay? Speed versus time. All right, so this is a bus, and we have the bus going. We have speed on the left. So we know if our speed is the same here, tells you what your speed is, 10 miles an hour here. The speed is at 0 miles an hour here. So if we're at 0 miles an hour, we are stopped. We are at rest. Okay, so let's look at that. We are at rest at C to D. So I'm going to go ahead and put that down here. At C to D, the bus is at rest. It has stopped. Okay, so we're going to calculate the acceleration here. If it's stopped, its acceleration is 0. Okay, so let's look at segment 0 to A. Okay, 0 to A, we are accelerating because we are increasing our speed. So we are accelerating. And let's calculate that, okay? So our final velocity is 10 minus our initial velocity, which is 0, over our time from 0 to A, which is 4 seconds. Well, about 5 seconds. So 10 divided by 5 equals 2 meters per second squared. Okay, so that 2 meters per second squared is my acceleration. What about A to B? So A to B, my speed is constant speed. And if our car is at a constant speed of 10 meters per second for 5 seconds, our acceleration would be final velocity at B, 10 minus 10 over 5 or 3. A to B is from 10, about 5 to 10, so about 5. So 10 minus 10 is 0, divided by 5 would be 0. So our acceleration is going to be 0 because he's traveling the same speed. 0 meters per second squared. What about B to C? B to C, he's slowing down, so he's decelerating. It's slowing down from 10 meters per second to rest in 3 seconds. So he's going 10 meters per second initially, then to rest, which is his finally. So at C, my final velocity is 0, minus my initial velocity of 10, divided by 3 seconds. Negative 10 divided by 3 is negative 3.3. So negative 3.3 meters per second squared. We've already done C through D. So let's look at the last one. The last one is D to E. What is the bus doing at D to E? So we know the speed is increasing, so we are accelerating. I'm gonna write that down. The bus is accelerating. And we want to know the acceleration. So D to E, my final is E. So my final velocity is going to be about 5 meters per second squared. 5 minus my initial velocity of 0 over the time it took from D to E is from 16 to 21. So 5 seconds equals 5 divided by 5, which equals 1. So my acceleration is 1 meters per second squared. Okay? So that is all you have to do today. Okay? So I want you to be sure you have those answers in there. All right? Have a great day.